Hey guys, happy Thursday. Let's just jump right into our Wednesday for DMR number 28. So, number one says, what are the prime factors of the number 81? So, prime factors. Factors are numbers that multiply together to give us a product, and then we will look for the prime ones. So, if our focus is 81, we need to think of numbers that multiply together, factors that give us 81. So we'll start with 1 times 81. Now, if you remember in our podcast that we did a couple weeks before we left school, they also taught you another trick that you can use at home since you have a calculator. And that is taking the number 81 and then dividing it by 2. If you get a decimal, then we aren't going to use those two factors, okay? And then 81 divided by 3. Ooh, okay. So this lets me know that 3 times 27 equals 81. You can even check it with reverse, the inverse operation. 3 times 27, boom, 81. Okay, in the podcast it said you can keep doing that for all factors 1 through 9, I think. So 81 divided by 4, not a whole number. 81 divided by 5, not a whole number. 81 divided by 6, not a whole number. 81 divided by 7, definitely not a whole number. 81 divided by 8, 81 divided by 9, and of course we know 9 times 9 equals 81. Okay, so looking at those factors, we're going to figure out which ones are prime. Okay. So 1 is neither prime nor composite. 81 is composite because we're looking for factors, and there's obviously more than 1 times itself. 3 is prime because it can be made with only 1 times 3. 27 is composite. It can be made with 1 times 27 and 9 times 3. And then 9 is 9 is composite because it has 1 times 9 and 3 times 3. I'm thinking that only 3 is a prime factor. Again, if you guys find any that I miss, you let me know, okay? All right, so 3, got it. It's prime. It's the prime factor. All right, let's roll on. Number 2 is which pattern below has a rule of +4? So we need to check each answer choice, A, B, C, and D, and make sure that we are following the pattern +4. So let's look at letter choice A. If I'm going from 81 +4, would I get 77? No, I should get 85, so right away I see that that's not fitting our rule here. Okay, for B, it says we need a +4. All right, let's try it. 33 +4, not 35. It should be 37, so that also doesn't fit our rule. All right, C, 2 +4. 2 +4 is 6. That one doesn't fit our answer choice. Let's do 68 +4. It does equal 72. I'm just going to make sure it works each time. 72 +4 is 76, and 76 +4 is 80. Voila, we found the pattern. Awesome job. All right, let's do number 3. Number 3 says the Town Theater made $2,599 last month. A ticket to the show costs $23. How many tickets did they sell last month? So we have a total price, and in order to figure out how many tickets they sold, I know that one ticket costs $23. So I'm going to divide out the total cost per, and then divide it by each ticket. and that should give me a total number of tickets sold. All right, so let's try this out on the calculator. Since it's a word problem, you are so totally welcome. Don't mind my kitty. Okay, it says they sold 113 tickets. All right, so there it is. 113 tickets. Everybody with me? We are rolling today. I love it. All right, number 4. Number 4, looking like it's going to be an elapsed time problem. I see a clock. I'm already thinking about it. So Joe left his house at the time shown on the clock. Looks like we're going to have to read it. And it says he drove for 8 hours and 26 minutes. What time did he arrive at his destination? And I'm also going to emphasize this word here. It tells us when he left the house. So let's look at the clock. The hour hand here is the shorter hand. It looks like it's almost at 11, but not quite. So it's still in between 10 and 11. So that means it's 10. And then the minute hand is on 10, which 10 times 5, because the clock is broken into 5-minute increments, 10 times 5 is 50. So the clock is reading 10:50 for me. Okay, then I'm going to sketch out a number line on my paper because it says Joe left at the time on the clock, which I know is 10:50. It tells us the elapsed time that he was gone for or driving for was 8 hours, 26 minutes. I'm trying to use all my scrap paper. And we want to know what time he arrives at his destination. So he's leaving, he's got a journey. We're trying to figure out what time he's going to get there. So let's start with our hours. I'm going to, let's see, I think I'm going to jump 2 hours first. So 8 minus 2 is 6. So 10:50, 11:50, 12:50. Use my fingers to count. Now I'm going to do the 6-hour jump. So 12, 1, 2, 3, 4, 5, 6, 50. And my hours are done so far. Now let's work on the 26 minutes. I know that if I'm at 6:50, I'm 10 minutes away from the next hour. So I'm going to go ahead and do a 10-minute jump to get me to 7 o'clock. And I'm going to take 10 minutes away from my elapsed time. So that tells me I need to jump 16 more minutes. When you look at what I'm doing there. And then since I'm at the whole hour mark, I feel comfortable jumping 16 minutes. Because I know 7 plus 16 more minutes is 7:16. All right. So that tells me that Joe is going to arrive at his destination at 7:16. Hi, kitty. Don't want to see my kitty. There she is. Hey, kitty. Okay, let's roll into the last problem. The last problem is an ordering decimal problem. It looks like our number 5s have been ordering decimals. And my paper just flew away, so we're going to do it right here. All right, greatest to least. We're going to order from greatest to least. I'm going to stack the decimals on top of each other on this side, just as they appear in the problem. So I'm lining up the decimal. I'm lining up the place value of each decimal. And then I want you to go ahead and start thinking about what can you put in those empty place value spots. If you said we should put a 0, 0 is our placeholder, you are correct. And then for me, it just makes it easier to compare when they are set up like this. So let's start with the greatest, since we're looking for greatest all the way to least. Okay, remember problem says greatest to least. So they all have a 0 in the whole number place, and they all have a 5 in the 10th place. So I'm going to move over to the 100th spot. I see 2 of the values have a 1. and 2 have a 0. So I know 1's larger than 0, so I'm going to look at the decimals that have a 1. And then I'm going to go over to the thousandths place to compare the very last digit. So this one is 510. This one is 512. I know that 512 thousandths is bigger or greater. So I'm going to mark that one off my list. And then I'm comparing that to 510 thousandths or 51 hundredths. It shows up like that here. Me adding that 0 does not change the value. So I can still write it as 51 hundredths. Or if you want to add that 0 in, that's fine. Okay. All right, those are done. Got my number line set up. Now I'm just looking at the last two. I'm going to just go ahead and look at the whole value. So 500 thousandths or 501 thousandths. I know 501 is larger than 500. So I'm going to go ahead and put this over here. And then the 500 thousandths is also written as 5/10. I want you to see the original number and when I added the 2 zeros. Remember, the zeros don't change the place value. Hi, kitty. So if I rewrite it on my number line like this, it is the same value if I added the 2 zeros in. All right. So that's the ordering decimals. You got your elapsed time, your word problem that you used a calculator for, worked on patterns, prime and composite with factors. We are done for our daily math review today. I'll see you again tomorrow when we'll finish up DMR number 28.